Right, in this video, I'm going to show you how to use the CPU simulator little manned computer. You can download this from the Google Classroom, and also you can find out information about the different mnemonics, that's the opcode instructions used in assembly language, from your course book. So it's well worth reading pages 85 to 90 of your course book to get a bit of background on what assembly language is and how to use it. But for now, all you need to know is that you've got different instructions, some basic instructions just for the AS course on the right here. There's 11 of them that we're going to use. Obviously, in a real CPU, there are many, many more, but there's enough there for you to understand the basics this year of how to use assembly code instructions. So each one of these does a specific thing in the fetch, decode, execute cycle in the process. So for example, the add command here adds a number from memory to that which is already stored in the accumulator, and subtracts a value which points to in memory to that of the accumulator, and so on and so on. And I'll show you some of these commands, but if you read the course book, it will take you through most of the commands that you need to know about. So first of all, then, let's have a look at the CPU simulator here. You can download this from from Google Classroom, and then basically you unzip it. Inside the zip folder, it's very important that you have these three basic files. That's the CPU simulator here, the database, which acts as a memory, and the DLL file. Now, if you haven't got access at home, there's a runtime system there. There's also a 64-bit one in the download file, which you can run, and it acts as a access reader if you need that. So all you do is once you've unzipped it, and you must unzip it, you double click that and it will run the simulator. Any of those files that are missing, just copy them across from the DLL file or download it again and it should work. Okay, then back to the simulator itself. Down this side, it's got some drop-down boxes with all the mnemonics in it. That's the opcode mnemonics. These are machine instructions. And on the this side is the operand value. For ease of understanding, there's no binary used in this, so that the operand is always a decimal value in the simulator, and that's always a mnemonic label and not its machine code equivalent, just like you would when you're writing assembly code. Over on the right-hand side, this is a view of the database, which is actually used as computer memory. So you can see that it's got a decimal value of the memory slot, and it's got the binary equivalent. Each one of these is a memory location, and there's 256 memory locations that you can use. Okay. The yellow part here represents the CPU, and you've got the ALU, control unit, and all the registers that we've talked about, apart from one other register, which is the IR register, which you'll learn about next year, but it just is there to signify that there's other registers in the processor. You've also got an area here to depict the data bus, address bus, and control bus. Okay, they're there really for cosmetic reasons, but there is a demo which allows you to actually, if you put switch up here, actually see one cycle in operation. You can see how they work. Okay then, so you can write your program here, and I'll show you how to load it in a minute. But first of all, we're going to prepare the way. You've got two boxes at the bottom here. One acts as an input stream, and one is an output stream. So, for instance, we could have peripheral devices like a keyboard that queues up in a buffer some key presses. And they could be the values that are in there. It could be a device sending information, a temperature sensor or whatever, sending information to the processor. On the output here, it's just like outputting peripheral, like a screen or some sort of data capture device there. So basically, we're going to use these two. So we're going to add something to the input stream. We're going to add two numbers. We're going to add the number 7. So we add that, and you notice that 7's gone in the input box, and the number 5. Add that, and you can see we've got 7 and a 5 there. And what we're going to do is we're going to write a little machine code program to add those two numbers together from the input stream, and we're going to send them to an output stream there. So the first mnemonic that we're going to use is we're going to get our first piece of input. When this has no operand value because it simply picks up the information from the input box there, removes it and puts it in the accumulator. So that's all it does. And you'll notice that the machine code instructions do simple things, and they generally end up by using the accumulator. The next one is we want to take that input, which has been put in the accumulator. So this is store. This is a store command, and it's store the contents of the accumulator at the address we specify. And in this one, I'm just going to store it in memory address 6 over here. So after that, then, we want to input the second value because we've got two values in there. And again, no operand. And we want to add the first value that we inputted to the value that's already in the accumulator. So that is stored in location 6. So we had location 6 there. So simply what that's doing is it's getting input, putting it in location 6 over there. It's getting the next number, which is putting in the accumulator, and then it's adding the number in stored 6 to that in the accumulator, and then we're going to output the result to the box down there. Okay. What's very important is we use the halt command down here, which ends the program. If you don't end the program, the code, the assembler will keep going through the memory, and it will eventually crash because it will read everything in memory, which is not necessarily machine code. Just to denote that we're going to store, this is like a variable, the dat is a data location. Just to show you that we could store some data here. And it usually uses labels rather than address. See page 86 of the book. We're going to put a dat there, and that will be where we're going to store the data, 6 and 6 there. So we're going to load this into memory. So we hit the load button here, and that loads it into memory. So you have to wait a bit, and you'll see the screen flicker or the CPU flicker, and you've done that, and that shows that it's loaded in. So now we can go through and fetch, decode, execute one after the other and watch it all happen. But I'm just going to simply run the program by clicking on run, and it just runs through like you would when you were using Visual Studios to run a C# program. But remember, this is small, discrete steps. So we're going to run the program now, and you can watch it going through the other side in memory, and you can see that the CPU is changing its values. So it's going through here, and eventually it's going to halt. And you can see that in the current instruction register, it's got the command halt. So it's got right the way down here and stopped the program. So let's have a look. We should have nothing in the input box because it's picked up the two values, the 7 and the 5. And it should have added them together, which 7 and 5 are 12, and put it in the output box. And that's simply, you've got there 1, 2, 3, 4, 5, 6 von Neumann fetch, decode, execute cycles. Okay, just a few other things about the CPU simulator. If we wanted to run this again, if we put reset all, it will reset the whole of the CPU, the memory. We'd have to write the program in again. If you just want to reset the RAM and alter the program on this side, you could just click that and it will zero the memory. If you just want to reset the CPU to run the program again without any values in the CPU, you can click reset the CPU. And if you wanted to reset the code individually, this code here, you reset that or reset all. So just be careful which one you click depending on what you want, or else you'll end up having to write the program each time again. So that's it. That's the CPU simulator that's written for you. So now you can experiment with these simple instructions. Right. Thank you for listening.